Alright, let's begin Lab 2 for AgEcon 305. This is our second lab, and it'll be on System of Equations in Excel. Just to remind you again, these online lab sessions that we have, they are replacing our Friday in-class meeting. This is a 3-hour class, so if I'm going to require you to take this kind of instruction and follow along and do a lab period, then it has to come from the sort of 3-hour weekly budget in the class, and so this counts as our third 50-minute session of instruction, even if hopefully this lab doesn't go quite as long as the last one. I think it'll go a little quicker. Okay, so this is our topic. Let's scroll ahead, and I'll take you through a few PowerPoint slides, which you also have on the web page for this lab. Okay, this is the instructions from the lab handout. First, note that this video is a demonstration, and we're gonna look at a simple example of two equations and two unknowns, and how we might think about presenting the information of two different equations. That could be obviously we'll be thinking about graphing those, but also how we might consider a solution to the algebraic problem of two equations and two unknowns in a spreadsheet setting. So the obvious application for economics is supply and demand, and that's where we're headed. So with that, we have some sort of objectives here. So first, modeling equations in Excel. What is a technique that we can use to do that? That documents the information we're putting in, that lets people understand sort of how we've set these equations up. The second part here would be how we go about graphing those linear equations or linear functions in Excel. The XY scatter plot is a graphing option that is there that is useful for that. And then finally, I'll use the goal seek tool. It's a function that's available in Excel to solve for what we call the equilibrium value, or the value where two linear equations cross one another. So in economics we refer to that as the equilibrium value, because it's where supply and demand balance out. But in regular linear algebra, there's no reason to think of that as anything other than a point that is shared by the two equations. So you'll follow along with the video when we start the demonstration part using the base sheet, the sheet called Base XY Model. And then when you start into the lab assignment, there'll be another one called the Beef Model that you work on your own using the stuff that's demonstrated in this lab video. Okay, we have just a few slides to move through here. I just want you to see what is going to show up in your spreadsheet. So this is the demonstration XY model that this lab video will actually focus on, and you'll see that I have typed in an equation here that is in sort of a generic form up in this top part. So equation 1 is, and in parentheses there it says a plus bx is equal to y. And so in this setup, we're going to call a the intercept and b would be the slope. Okay, so y is some unknown, x is another unknown, so that's two variables, and it can be described by two parameters. Okay, so the intercept, the value that y takes when x is equal to 0, and then the slope, how y changes every time x is increased by 1. Okay, and so that's what we have for equation 1. We also have equation 2 represented in the spreadsheet there. Down below, so it has a different intercept, a different slope, and so these are two different equations, and I change the way I write equation 2 to c plus dx is equal to y, just to note the fact that equation 1 and equation 2 don't have to be the same thing. Okay, so these representations for this intercept parameter and slope parameter on this side are different. Okay, so these are in Excel, these are just cells holding information for right now. The way we try to make them into equations will require us to add formulas, and that will be the steps that we go through as we fill in and build this linear equation model. On the beef side, a little more intuitive. So here, where the model that you'll build and use for your assignment or for lab quiz 2, we have quantity supplied is equal to A plus BP. So again, we have an intercept and a slope, and then I've labeled those A and B here. And then the demand equation is the quantity demanded is equal to C plus DP. Okay, and so C and D are the two parameters. And again, we have some other blank spaces here that we're going to talk about how we can use these in this lab demonstration, and then down here we have some more information that needs to be filled in that spreadsheet again. So these two mirror each other. So basically all the steps that we do for this basic XY demo will be the same things that you want to do for the beef model. Just as an overview here, so in systems and equations, two unknowns. We'll have talked about this by the time you get this video a little bit in class. The A, B, C, D, this sort of parameters, a good definition or a useful definition would be that these are just sort of the fixed values or the controls or the things that tell us how X and Y relate to one another. Okay, and so they are sort of given to us, okay, and we try to figure out how X and Y relate to one another using those parameters, so whether we're drawing a graph or whether we're talking about the slope and trying to calculate how X and Y adjust together. Those parameters are the key information. In linear equations, we only get two parameters, so we have an intercept, which tells us basically the location. How far up the y-axis is this straight line going to cross? Okay, so we use that to sort of locate it spatially, and then the slope gives us, you know, the true x versus y information. It gives us the rate of adjustment. You may have heard of this as the rise over the run, or in this case, it's the rise. It's the adjustment, the up or down motion in y as x gets adjusted. Okay, so let's walk all the way through our Lab 2 spreadsheet in slides here, and then I will move over to the actual spreadsheet and start filling this stuff in to give you an idea of the formulas to use. So our starting spreadsheet here is a two-equation system. It's generic. It doesn't represent anything other than just sort of a basic mathematics setup. The variables x and y in this case are common. Okay, so these are common variables in equation 1 and equation 2. So when you look at the labels here, x is x in this equation, and it's x here. It's y here, it's y here. The difference is in the parameters, right? So a plus b, c plus d, those values are at least potentially different, right? Because a, b, c, and d are different names. And so that's what's going to distinguish in this system of two equations, right? These are straight lines. This is what's going to distinguish how they look relative to one another, right? So if one has a higher intercept, we know that on the y-axis we would find that that straight line crossing at a higher point. And then here we just looking, right? You see one slope is negative and one slope is positive. So one of these will be moving upward in the first quadrant, right? As x adjusts, we'll see increasing values for one, and the other will see decreasing values. In the spreadsheet form, what we do though is we use cells to hold the results, right? So there's no way that we can take a cell here and just write an equation in and say evaluate that equation. So some of you may have used some math software in your life before where you could actually just type out equations, and certainly if you were using some sort of coding, some sort of language, some coding language that did math, you would expect to be able to sort of declare variables and then write the equations down and go from there. But spreadsheets are a little clunky in this regard. So what I've done is I've set aside 4 cells down here, and we'll go through how to use these in the spreadsheet. one for sort of x star. Now I'm going to call that my current value for x. And then here I've recorded two different values, so y1 star and y2 star. So from equation 1, if you give me some common value of x, say 0, we know that the value that comes out of the first equation describing x and y and how they relate to one another will be 5. y2, the value that comes out of this equation, will be 0, right? So it'll sit at the origin. And so for every common value of x, right, so think about moving along a horizontal axis or the x-axis, we'll be able to record a value from the first equation and the second equation, right? And they are both called y, right? So whatever y is, they are both trying to represent the same thing. And then I have one more cell down here, so I'm going to input values of x here. I'm going to calculate the y value from equation 1 here, the y value from equation 2 here, and in this final cell what we're going to do is we're going to record the difference between y1 and y2. So that means y1 star minus y2 star. And then our goal will be to think about how an equation system where we were interested in finding where two things cross could be solved by using these 4 pieces of information. Okay, so this idea of a current value for x star, evaluate y1 and y2, and evaluate their difference. And you probably already understand that if we can eliminate the difference, force y1 to be equal to y2, then we will have solved the system for where those two equations cross. Okay, and so this takes you through those steps. I didn't realize I had another slide here that was going to go through that, but that's exactly what is being discussed right here. So if y1 minus y2 star is the difference between those two values, that means that if we can force that y1 minus y2 equal to 0, it's equivalent to solving this system. We have other ways to do the analysis, and in fact the first thing we'll do when we get into our spreadsheet demonstration is look at using graphing to solve this. So one of the real perks of using a spreadsheet is lots of cells, lots of information. You can put formulas in really quickly and get them and cut and paste and get those to apply to many cells at once. And so that lends itself to making graphical depictions of data or equations. Even nonlinear functions are pretty easy to draw, so we'll see all of these things as we move through the semester. But that's what the space at the bottom of the demonstration or the XY model spreadsheet is for here. And so instead of having a sort of current value for x like we do in the space above, we'll have a set of sort of given values for x. So here I've put a range of values from 0 to 10. And then what we'll do is we'll calculate the y value using equation 1 for 0 through 10, and then the y value for equation 2 from 0 to 10. Then we'll use this information, these x values and both sets of y values, to calculate sort of different points that can be graphed, and we'll use the right graphing tool, and in that's that XY scatter where the points are connected to make straight lines. And what we'll have then are the two straight line linear equation plots that we need to think about our analysis. And obviously you might realize as you go through here, you might hit on the value where y from equation 1 is equal to y from equation 2. Since they're sharing this column over here of x's, if we find that value, then we'll know the solution directly from this table. Okay, and I'll just go ahead since I have this up, and then I can focus just on the spreadsheet after we leave this. Quiz 2, this is the submission part of Lab 2, will be due on September 6th. You need to type that. Don't just print out what you have in the spreadsheet. I don't need that. What I do need from you is if you make a graph and it asks for a graph, copy and paste that graph into a Word document where you can type something. Remember, every time we submit a graph in this class, whether I explicitly mention it or not, I'm going to ask that you please just put some description with it. Just explain it to someone. Don't just hand it off. There's a really good reason to do that, and I'll talk about it a little bit more, but it reminds you to label everything on the graph. Okay, it's because Excel helps you put a graph together so quick, it's very possible that you, in your mind, everything is labeled and organized well, but if you're forced to go back and write a description, then you'll notice that, yeah, maybe I didn't label the vertical axis as well as I should have. And so that's why it's good to always take your graph and put some explanation with it. So what you'll be doing in that beef model spreadsheet, and for the quiz part here, is sort of following the steps from the demonstration that we do in this lab for two equations. One is represented as the quantity supplied, and another one is the quantity demanded. So these are retail, this is the retail beef market, so supply and demand. The prices are measured in cents per pound. The quantity is pounds of consumption per capita per year. Okay, and so you'll follow through that and deal with these two questions. Beginning from what is the equilibrium Q star P star that solves both the supply and demand. So the equilibrium in a market is where there's no excess supply or excess demand, so we try to balance those out. So you'll be doing the same thing there. You'll be trying to find where supply and demand cross each other. Yeah, and then the second part we'll talk about what does it mean to shift this, and I'll talk about that just a little bit as we get to the end of the demonstration part here. Okay, I want to begin, let me take that away. I want to begin our look at this demonstration of how we're going to work with equation 1 and equation 2 in our demonstration spreadsheet here by thinking about the graphical approach first. Okay, so as I mentioned already, we have this space down here where it labeled data tables for graphing. Okay, I have a set of common x values here that I want to use, and then the first part here is finding the y value that go with each of those x's. Okay, and this is the first column is for equation 1. So using this intercept and this slope. Now I'm going to put the formula in, and I want the formula to be built in a way that lets me cut and paste, right? So I want to use the formula over and over. I don't want to type it in several times. So let's do our steps here. I'm at my keyboard, and I'm going to hit the equal sign, which is Excel's signal that I'm starting a formula. And then I'm going to go up here, and I'm first going to use the intercept. Okay, so I'm going to use a cell reference, my mouse, by mouse clicking in equation 1's intercept cell. Okay, so this means whatever number is being held in this cell will always be used as the intercept in this formula. Now it's a little, okay, so down here you see B4, so right now we just have this as equals B4. If you hit the F4 key on your keyboard, I just did it, you'll see that it adds $ in front of the B and in front of the 4. And what that is doing is that's sort of a freezing of that cell. So normally when you cut and paste and then you copy and paste to a new cell, Excel thinks that you want to calculate things row by row, and so it tries to adjust those. But we have a fixed intercept in this case, so we want, every time we calculate this, we want it to always refer back to B4. And so when you put that $ in front of the B and in front of the 4, you get what's called an absolute cell reference. And that absolute cell reference says just freeze the location, and every time I paste this formula somewhere, always go back and give me the value from cell B4. Okay, for a standard linear equation, if we continue the formula, we use a plus sign, and then we go get our slope. Okay, so it's intercept plus slope multiplied by the variable, and so let's add the slope, and so you see B5, and if before I do anything else I click F4, it will change and become an absolute cell reference as well, because I want to keep using that same cell as my slope coefficient for this equation. Now once I've got B5 referenced there as the slope, I hit Shift 8, which gives me the asterisk, which is a multiplication sign. You could also use the multiplier sign over on your number pad if you have one. I know a lot of you will be using laptops that may not have that, so it's whatever it takes to make multiplication happen, that's what you need to do. And then now we just need our x value, and the x value is from this column over here. And so I'll just click this cell, and that gives me A18 as the result. Now, because I want to copy and paste this formula down this column right here, I want A18 to be a cell that gets adjusted. Okay, so when I paste it to this cell right below, I want it to use A19 and then A20 and then A21. And so we're not going to do anything to this cell reference. We want it to remain the standard, the default type of cell reference, which is a relative cell reference. It means it's relative to the location in the spreadsheet. So it'll always look one unit or one cell to the left, and that's how it will find. That's how they will find the value to use. Okay, so I think I mentioned how to cut and paste or copy and paste before, but you can just wait till that plus sign shows up and drag, and you get these values: 5, 3, 1, -1, 3, -3, -5. So you see what's going on here. You could have figured this out just from looking at the slope, right? So we're getting an increase from 0 to 2, which gives a decrease of the y value from 5 to 3, and the slope is -1. So this thing is falling 1 unit every time x goes up 1 unit. We're going to repeat those same steps here for equation 2, because we want to look at both equations simultaneously. And so I'm going to start a formula here, and I'm going to mess up on my absolute references on purpose. So I hit the equal sign to start a formula. I go get the intercept in B8 for equation 2. I hit the plus sign. I get the slope in B9, and then I do my multiplication times the x value again in A18, and I have my value of 0. Okay, so when x is 0, y is 0. And just to show you what happens when you try to copy and paste this, you see that you get 1, 0, 0, 0. You know, you get a bunch of results that are nonsense because it keeps shifting this down. So it's using B9 and B10 and then B10 and B11, right? So B10 and B11 are not the right parameters, so we need to fix those cell references. We don't have to do any new typing though. It turns out that you can just put the cursor in the middle of B and 8 and hit F4, and it knows to go back and change that from a relative cell reference to an absolute cell reference. So even if you decide afterward or you made a mistake on the referencing, the cell referencing, you can either type in $ here or just put the cursor in there and hit the F4, or however you get function keys to work on your computer. F4 will make that conversion. And now I'm going to hit Control-C, and then I'll highlight everything and hit Control-V, and you see the new values for equation 2. Okay, and so now this looks a little better. When x goes from 0 to 2, y goes from 0 to 2, and that makes sense because this equation right here is really just y is equal to x, right? Okay, and so that's what we have going on there. So every time, whatever x value we take, we get the same for y. Okay, I've built these tables for graphing, and so now it's time that we actually build a graph to look at here. I usually start somewhere over here, try to click an empty cell, and then I go to Insert. And I know it's going to look small on your screen, but if you look through all the graphing options, or the recommended, I get this ribbon that says recommended, in the middle of my ribbon, under Insert, I get recommended charts. And so if you go over here until you find one that says Insert Scatter XY, then you are in the right neighborhood. And so I'm going to click the little down arrow to open the menu and get different options for XY scatter charts. And so I'm actually going to choose this one right here. So it has no dots in it. It's just straight lines that match up to X and Y. But really any of the ones, oh sorry, I want this one, scatter with smooth lines. So any of these here would be fine. In the top, this one won't have lines between it, but you could add them later. This one is just the one I'm picking. Okay, so I'm going to spread that out a little bit. And then once I have this field, this is why I went to an empty cell, you end up with this empty field for your graph, and now you can just right click in there and go to select data, and you end up with this data menu that we can use to add the data points that we want. And so the first thing I'll do is click on add, and the box that comes up says give the series a name, choose the X values, and choose the Y values. So I'm just going to call it equation 1. And then I'm going to use the red arrow here to select the range for X. So when you click that, you end up with, I don't even know what you call this, but you end up with this box that is ready for a range of cells. And so I'm going to choose that range right there from A18 to A23. Those will be my X values. And then move down here to series Y values, and I'll select B18 through B23 because those are the Y values for equation 1. Click on OK, and you see my downward sloping line. Everything looks to have graphed correctly. Click into this field again. We want both. We're going to put both equations, both straight lines on the same graph. So click in here, click select data, you'll get the menu again. And now, because we're going to add a new series for equation 2, we'll click on add. We end up with our little toolbox here again. We can type equation 2, use the red selectors, and we go get the X values. Use it here to get the new Y values. Remember, we're going with equation 2 this time, so we want these Y values. And then click on OK. Click on OK, and we have our results. Okay, so this graph gives us the upward sloping line we were expecting, the downward sloping line that we were expecting, but there's some more stuff that I'm going to do before I continue. So if you've had class before where I've done this kind of thing, you'll remember that I like to make the fonts big on my graph, so I'll just change that to like 18 so it shows up, and maybe I'll change those. So you just right click the axis where the numbers are, the category axis, click on font, and then just change it to a bigger size so it shows up better. But this graph is missing a lot. I want to add, I want to know what this axis is and what this axis is. So we need to find out how to do that. So it turns out, while you have your graph highlighted, when it's the active sort of element in your spreadsheet, you have this design ribbon that you can use. Okay, so if you go to the design ribbon and move all the way to the left, it says add a chart element. And that's what I'm going to do to add some labels to the vertical and horizontal axis of my graph here. So the second item is axis titles, and so it says primary horizontal, and so I'll add that one first, and I'm just going to call it X because this is an X and Y graph. Maybe for your beef model you would want to call it price or quantity, whichever one that you've put on that axis. You'll have to let me know, right, with your graph which one is where. On the axis titles for the vertical, I'm just going to put Y. Okay, and so it bothers me that those are so small. So see if I can highlight and yeah, make those big enough to read. Got it to 20. Okay. And then the other thing I might want to do, again going up into the design ribbon, add chart element, is add a legend. And so here it says that I can put the legend at the right, at the top, at the left, or the bottom. I'm just going to stick it down at the bottom of the graph, and again I'll just right click in there and click on font, and I want that to be bigger so that I can read it. Alright, so now I got a graph that shows me what's going on in these two equations. Not bad. And we had said that one of our goals here is to find out where they cross. What is that value where those two things cross? Well, when we have a graph, we see where they cross, we know that they cross. That means that we could do some investigation. You could get your ruler out, I guess, and try to figure out what those values are. There's some other options that you might consider. One of those would be to look at this axis and think about, what if there was a way that I could change this axis so that I get different intervals here, right? So what if this increased by a half a unit instead of 2 units every time? Well, to do that, you'd have to click on Format Axis, and I'm pretty sure that I just went outside of the screen, that's being captured for this. So I'll just tell you what I see. But it says under Units Major, it says 2, and that is how many. That is what the interval is between everything. If I change that to 0.5, you'll see first of all that the font I'm using is just too big to be able to see all that. But you can also see that getting the new grid line there says that the equilibrium y value is 2.5, right? Because now there's enough accuracy in this left-hand side of the graph to tell us that 2.5 is the solution value for y. When equation 1 and equation 2 cross over one another, 2.5 is going to be the solution value for y. I'm going to change that back because I don't need that. But you could do the same thing here. You could sort of squeeze out the interval until you get a really good approximation. So that's one way that people do this sort of thing. Let's see what else we could do with our graph. Yeah. So one of the nice things about having a graph, about sort of building this data table for graphing down here and then having the graph right next to it, is it shows us how adjustments to the parameters will play out. Okay, it shows us exactly what's going to happen. So if I were to think about, what if the slope for equation 2 was doubled, right? It's 2 instead of 1. How does that shift everything that's going on over there? And you see it makes it a steeper line. It changes. So we said before that the y value where they crossed was 2.5, which is somewhere down about right here. And so it's clearly at some new higher value. And so you can see that. Of interest for your assignment, when you get to the beef model, it's going to say what happens if the supply, I think it's if there's a negative supply shift or something like that. Well, this vertical line looks kind of like a supply equation or a supply line. And if that's going to shift, it's like taking a parallel version of this supply line and moving it to some other point. Okay, so moving it up or moving it down. And so you can see what that would look like by changing the intercept to maybe -2. And you see it shifts it down, right? So it takes the old supply line was up here and puts a new one down here. Now in your assignment, you're actually asked to show the shift. So you have both the original supply line and the new shifted supply line. And so the way to do that would be to actually extend this part right here, right? So you already have 2 lines being drawn, and now I'm asking you for a 3rd line. So I'm asking you for a demand equation the original supply equation and the shifted supply equation. So you'll need to add one column down here that shows the shifted supply equation, and by shifting I mean it has some different value for the intercept. Okay, and so that helps you, that's your hint for how to complete question 2 on the assignment. There are a few other things we can do with our graph before we leave it behind, or just to remind ourselves about how linear equations work. If you end up in a case where the intercept and slope of two different linear equations are exactly the same, then they lie one on top of each other, and so the solution of that kind of two equation system is everything, right? Because all the points that they have are in common. You have another situation that can happen with two straight lines, and that's when they share the same slope, but they have different intercepts, and that's parallel lines. So that's our shifted. This would be like this is downward sloping. It would be like a shifted demand equation. Okay, and so they have, but for equation 1 and equation 2 here, the blue and the red line, they don't have an intersection. You keep going out of the space that this graph is showing, and they'll never cross over one another. Let's switch back to this value. We have one other situation that could happen. What if the intercept of the supply equation shifted all the way up to 8? And so here we have a downward sloping demand, or downward sloping equation 1, upward sloping equation 2. They would cross. You could find a solution, but in economics we tend to think of all the variables being non-negative. That means they either are 0 or some positive value up this axis, or 0 and some positive value on this axis. So it's rare to think about negatives, especially in a market situation. So this situation where the intercept for the upward sloping part is higher than the downward sloping part is another sort of failure in the it's an outcome that can happen in two equation linear systems, but it's one that we would hope to never see. What we want is this situation. So the intercept for the upward sloping part is below the downward sloping part, and that means that they will eventually find their crossing point, or some equilibrium in the case of market supply and demand. They will find their crossing point out here in the first quadrant where things are non-negative. Okay, our last task here is to use this area of our spreadsheet and solve our model. So we've already tried the technique of using the graph and sort of approximating what this point is here. You might even, there's probably an option in your spreadsheet to hover over this and try to get an estimate of what that point is. No, I guess not. Okay, but you can try the intervals until you squeeze it down enough to find out exactly where that's located, but that's not a great option, and Excel is certainly built to do more for you than that, and so we're going to take advantage of that. So I said X star I was going to put in as some sort of a candidate value or category value or common value, and so a number to start with there could always be something like 0 or 1. It doesn't really matter which one you put in. And then what I want to do with Y1 star and Y2 star is actually use formulas, right? And so we'll relate those formulas to this cell right here. And so what I'm going to say is Y1 star, this is going to be a formula that always gives me the value of Y from equation 1 when this cell holds whatever value it holds for X. Okay, and so let's build that formula. So we start with an equal sign. We use our intercept, and we're not copying and pasting this formula, so we don't need to worry about the cell references. So we go with B4 plus B5 multiplied by B11. Okay, and so it says when X is equal to 0, Y1, equation 1 gives a Y value of 5. Let's do the same thing for equation 2. we'll go with equals the intercept from equation 2 plus the slope from equation 2 multiplied by this value in the x star cell, and we end up with this result. So just as expected, we get the 2 in it. We put x star equal to 0, we get the intercepts back, and then I want to use this fourth cell, y1 minus y2. We'll just put a formula in there that does exactly what it says it's going to do. So it'll be B12, that value of 5, minus B13. Okay, and the difference, the gap, is going to be equal to 5. And so you can look at the graph we've made over here and see what's going to happen. So our goal here is to use this cell right here, which has candidate values for x star, to drive this difference down to 0. And so it's easy just to think of it, following my mouse here, as 0 is a candidate value, 1 is, 2 is, 2 is, and then slightly bigger values from 2. Okay, and eventually you'll hit on that to where y1 minus y2 is equal to 0. That means that the gap has gone to 0, and whatever value for x does that is your solution value. It's the thing that balances this all out. Just like a price might balance out the market supply and demand to give equilibrium. Okay, and so you can see what goes on here. So we click in a 1 and the gap goes down to 3. Okay, so we could even draw a new plot over here to see what it looks like, but that gap would be 3. You plug in 2 for x, and the gap is down to 1, right? And so that's a height of 1. And so you might be able to figure it out just from the triangle here, but we don't need to do any of this sort of plugging in and checking it all out. We can get everything from a built-in tool in Excel, which is our last sort of information piece here in this lab. And so if you go to the Data tab, you'll get this Data ribbon, and under something called What If Analysis, you should have a tool called GoalSeek. If you don't have it, it comes with Excel, so if you don't have it, go to the help in your Excel and type GoalSeek, and it'll tell you how to install it. But that's what we're going to use. So if you click on, okay, again, this is under Data, under What If Analysis, go to GoalSeek. And what GoalSeek does, and I'm sorry, there's no way for me to make these little boxes that show up bigger, but what GoalSeek does is it gives you a target cell, or what it calls the set cell, and that's where you put the cell that you have a goal for. And so I'm going to click the little red arrow thing there, and our goal, or our target, is actually this y1 minus y2, right? The difference between the two equations that we have. So that's B14, and then it says, okay, that's your goal, or that's your target cell, and what is the goal for that target cell? And for us, it's to make it equal 0. Okay, we want y1 and y2 we want to find out where those two things are exactly equal to each other, because that will tell us the value for x that we want. And then the last piece here, it says, which cell can I change to try to make B14 equal to 0, the difference between y1 and y2 equal to 0. And so we tell it that, we give it the x star cell up here, B11. Okay, when we have all that done, B14 is the target should be set to 0, B11 is the thing that's allowed to adjust. Click on OK, and you see it races through a bunch of choices, just like we were talking about doing. We were talking about sliding over here and trying new values. Well, that's exactly what Excel's done automatically for us. It took this and found the difference in y1 and y2 to be equal to 0. You can confirm it right here, they're both the same. And it tells us that x star, this solution value for x, the value that you find moving along here that will balance these two out is exactly 2.5, and so that's our solution. Okay, let's jump back to our PowerPoint slides. That's the solution here, so I will just remind you I'll just point out to you in part 2 here, there is this hint. So we talked about it as part of the lab here, but the way you want to consider the shift is to change the intercept. So we don't have a shift variable built in yet. We will in future models, but I want it to be as simple as possible here. So just change the intercept, get some new value, and record those to make a new line to graph it, and you'll be fine. Both of the equations here should be things that you type out answers to and submit, and that'll be that. Okay, you have a beef model. It looks like this. The only difference really is the equations now are quantity supplied and quantity demanded. The equilibrium condition is that QS is equal to QD, or in this case, when you're doing your goal seek here, QS minus QD, the target is going to be set that equal to 0, which is the same thing as saying QS is equal to QD. All right, with that, I'm gonna stop recording here, and this will be the end of our week 2 lab. If you're watching this over Labor Day vacation, I hope it's going well for you.